All right, am I audible, everybody?
Yes, ma'am.
Yes, ma'am.
Yeah,
Audible, ma'am.
audible, no? Okay. So we'll just do a recap. Yesterday's class, we learned about what is pressure, okay, fluid pressure, and we also learned about the unit. So I told you how to specify the units for pressure, which is exactly same as stress, but we learned that it is not a vector component but a scalar component. 1 Newton per meter square equal to 1 Pascal. All right. We also learned about bar, atom, okay, kgf per centimeter square, and also the English system, that is the pound force or in psi. Okay, so that's what we learned. We also learned about what is absolute pressure, gauge pressure, and vacuum. Do you have any doubt in this? Any clarification?
No doubt, ma'am.
No doubt. Okay.
Mm.
So pressure at a point, all right, is the same in magnitude and in all directions. Okay. So in a particular horizontal direction, the pressure does not change. That is one of the main points we learned. Okay, and it's a scalar component. And yeah, we also learned about gauge pressure is nothing but atmospheric pressure plus the actual absolute pressure. Okay, so you have, we also learned about Pascal law, when at any 2 points in a fluid, flowing fluid in the same, flow, you have P1 equal to P2. Okay, so this can basically be used for if you want to lift, for example, for hydraulic jack. That's the example we saw in the last class. Okay, so some of the main points. So pressure in a fluid, how do you calculate the pressure in a fluid? It's not affected by area, but just by the height. Okay, another most important point is pressure in liquid acts equally in all directions. All right, so it's not affected by shape, size, or surface area. All right, at that particular point for the same liquid, okay, the pressure remains the same at the horizontal height. But with respect to height, the deeper it goes, the higher the pressure. Okay, and this is how we calculate. If there are three different liquids altogether, we can just calculate the pressure and by rho g h1, h2, and h3. Okay, and some of the applications we that I want to highlight today is public water system. If we see the water of a river or dam, this is the river, it's pumped to a higher level, elevation. Okay, so that the water flow has sufficient pressure to flow to the consumers, okay, which is located at lower levels. All right, so every home has a water tank which is at a higher level. So you need to provide a particular pressure. All right, so if it is flowing from a higher elevation, automatically the pressure will be more at the lower point than the higher portion. Okay, regarding blood transfusion, a bottle hung at a higher position so that the liquid solution has sufficient pressure to flow into the veins. It should have the same pressure, only then it will flow inside. All right, construction of dams, this is something which is very applicable to your field. Water at the bottom will be higher pressure than the top. Why? Because of gravitational force. All right, so pressure at the top is higher. So if you have a wall, you must have all noticed the dam, okay, wall, the area of the wall at the bottom is more than compared to the top portion. So the wall of the dam has to be thicker at the bottom to sustain greater water pressure. Okay, for example, if you take a submarine, all of you know what submarines are, right? They submerge into the water and they float inside the water. Okay, so the greater pressure is exerted on it, so the shell of the submarine should be of a greater thickness. Okay, the wall has to be thick so that it can withstand enormous pressure at a greater depth. Okay, so today's class, are you guys clear with the concepts? Okay, so basic concepts here is P can be measured with rho gh, and it acts equally at same direction towards the molecule. Then it does not depend on the shape, size or surface area. Deeper you go, more is the pressure. Okay, so that is the main points we learned in the last class. So today's class we will go ahead and learn about the pressure measurement. Okay, so how do you exactly measure the fluid? Okay, the pressure in the fluid. So all of us know it is measured in kPa. Atmospheric pressure at sea level is 1 atom. It can also be in mercury. It can be given as 76 mercury. Okay, or 101 kilopascal. This is the standard pressure. Okay, atmospheric pressure. In outer space, the pressure is generally 0. The pressure in vacuum is also called as absolute 0. All right. All pressures referenced with respect to this 0 pressure are termed as absolute pressure. So what is absolute pressure? All the pressures which are measured with respect to this 0 pressure, which is the absolute 0, is called as the absolute pressure. So atmospheric pressure is measured with absolute pressure. Are you guys clear about this?
Yes,
Yeah.
ma'am.
Yes, ma'am.
So now if you say, we will take two measurement types. Okay, one is barometer and the other one is manometer. All right. So the barometer, you have uh, okay, let me just, another concept that we need to understand before we go ahead is many pressure measuring devices measure not absolute pressure but only difference in pressure. This we have to understand. So that is nothing but gauge pressure. For example, this is the vacuum pressure, mercury, height of the mercury column, okay, which has increased, and this is the pressure being measured. So we are going to compare two pressures, vacuum pressure as well as the pressure to be measured. So it's basically all the measuring devices, okay, it will only measure the difference in pressure. Okay, so there should be some standard pressure with respect to that. For example, atmospheric pressure, we will measure. It will compare with the atmospheric pressure, or it will compare with the mercury pressure. Okay, so whenever atmospheric pressure is used as a reference, the possibility exists that the pressure thus measured can be either positive or negative. See, if it is below atmospheric pressure, it is negative gauge pressure will come. So it is also termed, those negative gauge pressures also termed as vacuum pressures. Now, just to do a recap regarding this, we learned about this. This is the atmospheric pressure. Okay, below this is known as vacuum pressure. Above this is called as gauge pressure. Okay, are you guys clear about this?
Yes,
If
ma'am.
you're
Clear.
measuring, yeah, if you're measuring with respect to atmospheric pressure, if it is a negative value, it will be known as vacuum pressure. If it is a positive value, it will be known as gauge pressure. I hope it is clear. Okay, so that's what I have explained in this diagram. So you have this particular, for example, this is a beaker, okay, with mercury. All right, and you have uh, another tube with mercury in it, and you invert it. Okay, this height will tell you the pressure of the mercury. Okay, this height will give you the pressure of the mercury. All right, so these are the uh, different types of manometers that we have. We'll be learning about two measurement techniques. One is manometer and the other one is called as barometer. Okay, so before we go ahead, I want you to write down fluid measurement as the heading in your notes. Finish writing. Finish writing? Fluid measurement. Yeah. Okay. Now you can write it as see if we first. Okay, no need to write all this. Wait. All right. First, we will take what is a barometer. So now write down barometer. Finished? Can you all open your videos that I can be? I don't have to wait for you to unmute. Yeah, thank you, Albin. Yeah, thanks, Swati, Akash, David, Aljan. Rest of you also can please open your videos. Yeah, thank you. So barometer. Okay, now let's go ahead with what is a barometer. Now you see a mercury in a vessel. Okay, and generally atmospheric pressure is measured by a device called a mercury. 1 minute. There's some noise. I don't know what that noise is. Okay, so atmospheric pressure is measured by a device called barometer. Okay, and it is also known as barometric pressure. Now, if you see this particular diagram, okay, there's point B and there is point A. Okay, and A is denoting the area. So all of you know that the area of the tube has no connection with the atmospheric pressure. It's only the height which is important here. Okay, now in this is also mercury. Inside the tube is also mercury. Okay, and this is nothing but air, normal vacuum pressure. So what we are doing here is we are taking a tube full of mercury and we are overturning it inside the mercury fluid. So this point, B point, will denote the atmospheric pressure. Okay, so this barometer is basically to calculate the atmospheric pressure. Okay, so PC can be taken to be 0 since there is only at point C, okay, the pressure can be taken at 0, okay, vapor above, because there's only vapor above the point C and it is very low to atmospheric pressure. So obviously you know that the pressure at the top will be lowest and at the bottom it will be high. Okay, so what will be the atmospheric pressure? PC plus rho G H. Okay, the H height. So PC is going to be 0 because it's vacuum pressure. Okay, so change in atmospheric pressure due to the elevation has many effects. Okay, so rho GH. So you all can write this, draw this diagram. Okay, and write this equation. Basically, this is used to calculate the atmospheric pressure. Vishu, are you writing?
Yes, ma'am.
Okay. All right. So you all know that there's a change in pressure due to elevation. Did you find, is anybody in hill station right now, Ooty or Munnar or anywhere? Or have you gone to any hill station, Kodaikanal? Yes, Akash is nodding his head. Even David has gone. What about Swati? You did not go anywhere? No? Okay. Maybe you should ask your mentor to take you out, okay, as a class to Uti. Okay, so when we go to a hill station, the atmospheric pressure is different. Okay, the atmospheric pressure will be different. Okay, because the altitude is high. All right, at sea level you have a particular atmospheric pressure, but when the altitude changes, okay, when the altitude changes, the atmospheric pressure is high. Okay, so what happens here is the temperature also differs, and I'll give you some examples like cooking. Okay, it will take longer time to cook in high altitudes. All right, because the temperature is low, the boiling temperature reduces. I told you in the previous class when we were learning about vapor pressure. Okay, when the pressure outside is changed, automatically the boiling temperature also reduces. Okay, it will not wait till 100 degree. It will generally 100 degrees Celsius boiling temperature happens. Okay, but in a lower value also it can boil. So if the pressure is low on top, automatically the cooking also will take less time. Okay, now coming to nose also bleeds. All right, when you go to high pressure, because the nose vessels is not able to withstand the high pressure outside. Okay, outside the body. All right, that's another example. So the blood pressure and atmospheric pressure, the pressure between the blood pressure and the atmospheric pressure is larger in high altitudes. Okay, and in lower altitudes it is less. So there's no blood flow. Okay, so knowing, calculating the barometric atmospheric pressure is very important. Okay, for various reasons. So you can use a barometer to calculate the atmospheric pressure. So the methodology of calculating is very simple. You just need a mercury, okay, in a beaker and in a tube, or a tube and a beaker. So you can use the formula rho gh to calculate atmospheric pressure, which changes with respect to time and altitude. Not time, sorry, temperature and altitude. Okay, so if you want to measure atmospheric, sorry, one second. So it's the same thing here. Now let's go to manometer. Please write the heading as manometer. There are different types of manometer we have. There is U-tube, which is a very common one. We saw it in the lab last class. There's inverted U also. There's enlarged leg. Okay. And there is inclined tube. All right. So inclined tube is basically used for better precision. Okay. And what exactly is a manometer? So you have an elevation change of delta Z. Last class I told you there'll be an elevation change in delta Z. So you want to find out the pressure in this block. Okay, it has a particular gas. So you need to find the pressure. So manometer is a U-tube manometer we are using here. It connects with the pressure to be found. Okay, and the pressure in this fluid. All right. So if you take this level, at this side on the left side 1 and the right side is 2. Okay, so pressure at this level will be the same. Got it? Pressure at this level will be the same. Okay, so you can find out the elevation change in a fluid at rest corresponds to this. Okay, so the pressure difference between this liquid and this liquid you can find out using this equation, that is change in pressure equal to rho g and h. Same thing, rho g and h. So the h is calculated from this line 1 2. Okay, so manometer consists of a U-tube containing one or more fluids such as mercury, water or alcohol. Why is it mercury is used? Because the density is higher. If you have water, the height will go even more higher. Okay, so why should you use a tube which is a longer tube. Okay, it will only cost you more money. So you can use a higher. So heavy fluids such as mercury are used if large pressure differences are. Another requirement is if you want to calculate large pressure differences, you can use mercury. Otherwise, water, alcohol, or oil also can be used. Got it? So can you all draw the diagram and write this equation? Finished, everybody?
Yes, ma'am.
Done now? Okay. All right. So the next thing. So now, for example, if you have a multi-fluid manometer, how do you calculate? Okay. So for multi-fluid, for example, now you have fluid number 1, 2, and 3. On top, it is atmospheric pressure. Okay. So you have to write P2. So you want to calculate the pressure at point 1. Okay. You know there is atmospheric pressure, so you have to add this plus pressure at fluid 1 plus pressure at fluid 2 plus pressure at fluid 3, and finally you will get P1, pressure at P1. Okay, so pressure increases downwards and it decreases upwards. It will increase downwards, so that's why I have given the darker shade here. Okay, 2 points at the same elevation in a continuous fluid are the same. So if you take 2 points, here 1 point, here 1 point, obviously it will be the same pressure. Okay, but with depth it will increase. Okay, and if it come up, it will decrease. Okay, so how do you give the pressure in terms of rho gh? So P1 will be equal to at point P, this is point 2. Okay, so atmospheric pressure plus rho 1 gh1 plus rho 2, because density different fluids are there. Rho 2 gh2 and rho 3 gh3 equal to P1. Okay, so you can easily calculate. So here, if you see, there is air, this is water. Okay, here it is oil. All right, and here again it is mercury, and this is point 2. Okay, so you have P2, which is air, plus rho 1 g h1. Okay, and then rho 1 g h2, this point. Okay, and then rho 3 g h3 will be equal to P1. Okay, when we do problems, you will be clear. All right, so there are so you can also calculate, see, when all these cases fluids are at rest. Okay, all these cases fluids are at rest. So I want you to write the heading as multi-fluid manometer. Draw this particular diagram. Do we have time? No need, you can draw it. I'll share the PPT. You draw this diagram and write this equation. Okay, and measuring pressure drops. Now in this particular thing, it's the same fluid, but it is flowing. So I want to calculate, and for example, that's what we did in the experiment for the last exercise. Okay, at pressure at point 1 and point 2, there will be two different pressures. So you need to find out the relation. That means the difference in pressure in point 2 and 1. Okay, so we have to connect the manometer to point 1 and then connect the manometer to point 2, and inside it is mercury. Okay, this might be the fluid which is required. So how do you calculate? Okay, relation for pressure drop P1 minus P2 is obtained by starting at point 1 and adding or subtracting rho gh terms until we reach the point 2. Okay, so if the fluid in the pipe is a gas, all right, so P2 will be greater than P1. Okay, so P1 minus P2 will be rho G and H. This is the difference. This is exactly what we did in the this thing. Okay, so can you write this down? I think I will. You can write it in your free time. All right, and the last one is Bourdon tube pressure gauge. There are so many pressure gauges available these days, which will measure the pressure in a mechanical system. Okay, so mainly for a fluid we use barometers and manometers. Okay, but there are electrical systems also, like transducers, gauge pressure transducers, Bourdon tube pressure gauge. It's a very simple thing which I just want to explain once. Okay, it works on a simple principle of a bent tube. So now you have a tube here. This is connected using a lever with a needle. Okay, as this tube shifts this side, automatically the needle will show the scale. Okay, so it gets bent due to the shape of the Bourdon tube. So as pressure is applied internally, so pressure is applied like this, in this direction. Okay, you see this is the gauge and this is how it looks like. This here pressure is applied. Okay, the tube straightens and turns into its original form when the pressure is released. As the pressure is applied internally, the tube straightens and returns to its original form when the pressure is released. The tip of the tube moves with internal pressure change and easily convert the pointer onto a scale. Very simple concept. So what happens is when you apply pressure the shape and remove the pressure, the shape of the Bourdon tube, it straightens and returns to its original shape. Okay, so that is your Bourdon tube pressure. So tomorrow's class, what we will do is we will solve some problems based on the barometer and some problems based on manometer. Okay, with this we complete today's class. So tomorrow's class we'll do some problems. Okay, and last time I think the quiz, all of you had a trouble answering the quiz. Okay, first of all, I think it was not clear. So I'm going to use quiz. Quiz is another platform, online platform. Is that okay, everybody? So come prepared. Tomorrow we will have a quiz. Okay, and we will solve some questions. And also I want to take a feedback. Okay, so another instruction for the feedback is, see, basically it's an online platform and I want you all to understand the subject the way we teach in class, which is not possible, but at least I can improve the delivery by knowing frank feedback from all of you. Okay, so you should, when you log in to the quiz, it will be an online quiz. Okay, like I took last time, but different platform. Now when we take the quiz, no, don't log in with your name. Is that okay? Okay, for only for the feedback. For the feedback quiz, I don't want you all to log in with your name. Just write some random name like ABC or something. Okay, so that you can give frank feedback so that I can teach you accordingly. Is that okay? All right,
Yes,
so
ma'am.
because I need
Okay,
to
ma'am.
understand whether you're able to understand or not, because behind the screen, in class I can monitor, but in the screen it is little difficult for me to really know whether you're learning the subject or not. Okay, see, this is an analytical subject. We have to understand every point, okay, clearly, and you should be able to solve all the questions. Okay, so that's what we will do in the next class. Is that clear? Okay, so everyone please join in by tomorrow. What time is our class? Is it at 11? I think it is in the same hour, 11 o'clock. Do we have class tomorrow? Yeah, we have class. Okay, so
No.
yeah, 11 o'clock we'll have a class. So 11 to 11:10. I will take feedback first. Okay, then 11:10 we will have that. We will solve the questions. If we don't have time to solve, don't worry, we will solve it in the lab hour. Is that okay?
Okay, ma'am.
Okay, ma'am.
Okay. Yeah. Thank you. Thank you for your response. All right. So that's all for today. Every other class, I've always taken 5 minutes extra. So today I'll close it 2 minutes early. Okay. So have a nice day. See you tomorrow.
Okay, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you. Thank you.